Recently, a loud narrative is circulating that skills have killed the Model Context Protocol, claiming the older way of connecting tools is dead. But pitting them against each other misses what they actually do. They operate at entirely different layers of the software stack. Get this integration wrong, and you will either choke your AI's memory window with thousands of useless tokens or expose your enterprise to massive security vulnerabilities. The reality is, MCP was built to solve the integration problem, standardizing connections to external data. Skills were built to solve the context saturation problem, managing how much information an AI has to hold in its head at once. Conflating the two leads to days of wasted engineering, building infrastructure that doesn't actually fit the workflow you need. To see how they fit together, think of your AI agent as a chef in a commercial kitchen. MCP tools are the raw ingredients and the heavy appliances. They give the chef the physical capability to open the fridge, search a database, or call an external API. Skills, on the other hand, are the recipe cards pinned to the wall. They provide the step-by-step instructions for what to do with those ingredients to produce a specific meal. This matrix contrasts them across 5 dimensions. Left is MCP's client-server integration. Right is Skills' localized files. Looking closely at row 3's invocation, MCP uses strict schemas and typed parameters in a separate process, while Skills run local scripts directly in the agent's environment. MCP gives the agent the what, the raw capabilities. Skills give it the how, the behavioral instructions. The biggest criticism of MCP stems from how most systems implement it. They load everything at once. When an agent boots up, it often pulls the complete JSON schema for every single available tool into its context window. This immediately dilutes the model's attention, increases network latency, spikes API costs, and drops reasoning accuracy due to unused tool definitions. Skills bypass this memory bloat entirely using a pattern called progressive disclosure. Instead of loading the full schemas up front, the AI receives a lightweight index, usually just a list of skill names and one-line descriptions. It only pulls the full markdown instructions into memory when a specific task triggers the need for them. Because skills are written in natural language rather than strict schemas, they rely heavily on the AI's ability to interpret those instructions correctly, which introduces a margin of error. They protect your context window and keep costs down, but they trade the predictability of a strict API for the flexibility of natural language. Beyond memory management, we have to look at where the code physically runs. Skills execute locally. The agent invokes capabilities by running Bash or Python scripts directly in the host's terminal. This allows for lightning-fast iteration. You can edit a script, save it, and the agent instantly picks up the change without ever needing to rebuild. But scripts relying on local dependencies are fragile. A Bash script built on macOS can break completely when handed to a colleague running Windows. MCP solves this hardware dependency issue by decoupling execution entirely. It uses a standardized remote procedure call model. The agent talks to a server, and the server executes the work. The agent doesn't need to know what language the server is written in or where it lives. Setting up an MCP server requires dealing with JSON RPC over HTTP and introduces network latency for every call, but in return, it abstracts the local environment away. Skills prioritize raw iteration speed for a single developer. MCP prioritizes cross-platform stability for an entire team. When you move into production enterprise environments, the priority shifts entirely to authentication and permissions. To use external services with a local skill, developers typically have to pass global API keys directly into their shell environment. Giving an AI unauthenticated shell access paired with global credentials is an immense risk. A hallucinating model with a live token can cause severe damage without any oversight. MCP addresses this by routing external requests through a centralized server that natively handles OAuth protocols. The agent asks the server to perform actions on Beam behalf. The AI never touches raw credentials, and every request flows through a choke point, enabling precise audit logging. If your agent needs to write to a live database or interact with external SaaS tools, the security model of MCP is non-negotiable. So how do you decide which to use for your next build? It comes down to identifying your specific profile. Start by asking, what does your agent need to do? For querying live databases, deploying code, or interacting with Jira and GitHub, default to MCP for secure connectivity. To teach an AI a local SDK or enforce offline coding standards, default to skills. Correctly identifying your use case upfront prevents you from over-engineering a local workflow or under-securing a production deployment. Ultimately, the most capable AI orchestration systems don't choose between them. They fuse both architectures together into a single cohesive workflow. In a hybrid model, the local skills operate entirely as the behavioral runbook, while the MCP servers provide the secure muscle. The agent reads a lightweight skill file to learn the optimal patterns and workflows, which then instructs it exactly when to trigger a heavily authenticated MCP tool. Maintaining this clean boundary keeps your tools from becoming bloated with instructions and keeps your instructions from becoming brittle with hard-coded scripts. By mastering both protocols, you provide the instructions and the secure capabilities your AI needs to function as a